Was in 1989 that we were reminded once again of the devastation that earthquakes can cause here. And in the building of the new San Francisco Library that we just showed you with Steve, the pictures from Loma Prieta reminded planners of what's at stake. So how to protect 1.5 million books, 5 million documents, and 32 miles of stacks. News Center 4 science reporter Brian Hackney explains.
They'd been working on the blueprints for more than a decade. But they didn't plan on this.
The crack just suddenly opened up, and it just was so quick. It was just like a rifle shot. It just, boom, it was open.
And it just kept coming, and it kept coming, and it kept coming again.
The Loma Prieta quake destroyed buildings and collapsed freeways 60 miles from its epicenter. And after the quake, library architects got another shock. This one. In this 1990 circular, geologists figured there was a much bigger chance of a much bigger quake near San Francisco. The library would have to be reinforced to withstand a magnitude 8. By then, the design of the building was 90% complete, but they had to redesign it literally from the ground up. Now, you might think that that would present a great problem.
It was actually a great challenge because there's a time that we as architects have to become very inventive.
They decided that if the ground was going to shake that hard, they wouldn't put the library in the ground at all. The whole building is actually suspended in sort of a bathtub, surrounded by a moat. You can see it outside, the flexible joints designed to move up to 18 inches during a quake. Most fascinating of all, the whole library is actually sitting on top of shock absorbers, these cubes of rubber sandwiched in steel plates called base isolators. 142 of them in the basement support the foundation of the entire building.
The idea is that these 142 isolators will actually absorb the ground motion or the earthquake motion.
It's as simple as that. They're shock absorbers for the library. In a big quake, there won't be a whole lot of shaking going on.
Naturally, it comes out that this is the system which will work because it reduces the forces by 5 times compared to conventional building.
Computer models show that in tall buildings anchored to bedrock, a quake's motion is tremendously amplified on the top floors. But just like shock absorbers in a car, the isolators will take some of the shock out of quakes. And since the air ducts can flex and the power lines are made to move, the library is the best place to check out modern seismic design.
And it really took a lot of ingenuity and creativity on the part of the architects and the engineers to solve this problem.
But apparently you did.
We did.
And good thing. The USGS is expected to issue another quake forecast for the Bay Area, and the probabilities of a big one are probably going up. In San Francisco, I'm science editor Brian Hackney, News Center 4.
Boy, you'd like them to come and do your house, huh? Well, you can take your own high-tech tour of the library on CRON's website. We have pictures, information on the library's computer and multimedia services. The website address is cron.org.